Hi, it's Mr. Steinert. I'm going to give you a little introduction to what we're going to be doing in the next week or so. Um, as you know, chemistry is the study of matter, energy, and change. And the story so far, remember in Unit 1, you discovered that some changes to systems increase the mass of the system, some decrease the mass of a system, and some don't change the mass of the system. But all of them can be explained by envisioning matter as being composed of very small particles. You began by looking at bulk properties of matter, like mass and volume and density, and discovered that different materials have different properties, but that those properties depend on their temperature, pressure, and the phase of the substance, solid, liquid, or vapor. In Unit 2, you moved on to investigate the properties of gases, one of those phases, and develop an understanding of how the pressure, volume, temperature, and number of particles were related to one another. Then in Unit 3, you extended those particle models to include solids and liquids and discovered how energy transfer and storage change the phase and the temperature of substances. You'll notice that we started with properties of matter, mass, volume, density, pressure, temperature, and phase that can be described using a particle model that treats the particles as simple BBs. No internal structure is needed. In Unit 4, however, the internal structure becomes important because some substances, those particles we've been dealing with, are actually compounded of simpler particles in definite ratios, for example, H2O. For that reason, we call them compounds, because they're made of more than one type of particle. So thus far in Unit 4, you've investigated the evidence that Dalton, Avogadro, and Lavoisier used to explain how atoms form compounds, and also how Thomson discovered that atoms are composed of positively and negatively charged parts. The Sticky Tape Lab, which you'll begin today, will give you insights into the behavior of charged particles and help you develop a more complex model of how particles acquire charge and how they interact with other charged and uncharged particles.